now. Okay, Babisan, I think we're now on recording.
Yeah, sure. I'm also seeing the recording mark.
Okay, so now we will start with, we have right now, we have three basic virtual machines. One is the master node here, an example. They're actually located on different locations. Hence, you can see we have a different IP address. So we have master node, we have worker node number 1 and worker node number 2. We don't have to do anything because the FabDep framework will do the installation for us. So let's start now with setting up our fabric network. This will also help us educate what is the composition of the fabric network. So this is the dashboard of how you want to control the fabric network using the FabDep. FabDep means fabric deployer. Now, the very first concept of the fabric deployer is we have a cluster, which is your Kubernetes cluster, and you want to link that with your fabric network. Right now, we don't have any cluster yet. So if you go to the list, it's empty. And if we go also to the network, we don't have any network. So this is a fresh setup. Now, the very first thing that we need to do before we can actually create a fabric network is to create a cluster. But we don't have to do that manually. We will let the fabric network, the FabDep, to automate the deployment of the Kubernetes cluster for us. So we will start. So first, let's create our cluster. So when you define a cluster, all we have to do is just specify the name. So in this case, maybe we call it the Wrappy cluster. We specify the master node, meaning we just assign, very easy to set up. We just have to specify which IP address and the username account that allows us to log into the master node. So in this case, we call our master node to be master, and all we have to do is just copy the IP address. So if we go back to the Microsoft cloud, we have here, this is the master. So we'll just have to copy this IP address, and then we will put it here. Now we will specify the account. So in this case, I have created a username. Just to verify that I input the correct password here. Now, most important thing when we create a Kubernetes cluster is that FabDep has a way to verify if the account is correct. So we can click on this icon to verify that there is actually a connection to this machine. So it's now checking. If you can see the icon now, you can see the green check mark here. That means it has verified that it can connect to the master node. Now we will try to add a worker node. We call it a node 1. And then we'll just copy the IP address. So this could be any virtual machine. It could be hosted in a private data center, or it could be hosted in a cloud, or a combination of cloud and private data center. So let's just copy. And then we specify the login, just to verify that information, and then we will verify the connection. Okay, so we have the green mark. That means we're good to go. Now, what we are going to set up right now is a cluster with 1 master and 2 nodes. So what we will do, we will add one more, node 2, and then we'll just basically go back to our cloud and then copy the second node, this one. We will copy this one. So this is another machine. And we will type the username and password just to verify that the username and password is correct. Yes. And we can click on the verify connection. Okay. So now we have verified a connection from the master and the node 1 and the node 2 of our worker nodes. All we have to do is very easy. Just click on add cluster. and FabDep will do everything for us. So let's try to do that. Okay, so the very first step, this will actually take a while. So the very first step is it will set up the master node. That means it will install all the software for us, from the Kubernetes to the Docker to everything. It will do everything for us. We don't have to manually do it. Now, since this will take a little while, maybe around 5 to 10 minutes, in the meantime, I will also create one more node because we will try to add one more peers later on manually. So what will happen is once we have our public network, when we have our cluster, how easy is it to add one more node? So let's try to do that. Just while waiting for the cluster to set up, we will create one more node in our virtual machine. Okay, so I will create, this is, by the way, a Microsoft platform. So let's call this node 3. Just use the Southeast Asia. I'll use a username here. So what I'm doing now is basically I am creating a new virtual machine so that I can demonstrate how easy is it to add a node once we have completed our setup. This is actually while waiting, so let's just see the progress. Okay, it's still processing on, this will actually take a while. So in the meantime, let's create our node number 3. So I will create this one. Now, if you will notice in our progress, it has completed the setup for the master node. Now it is setting up the worker node. We don't have to do anything. FabDep will do everything for us. So let's just wait for a while and let's go back here for our third node. Okay, so we have now a running third node. Let me just quickly set up that. Make sure that we can log in. I think I have the wrong password. I think I typed the wrong password. Let me just reset the password. I think I mistake. We can reset the password. Let's just go back here. It's not finished yet. Oh, okay. We have completed our cluster. We have, if you will notice, we have a two cluster, and we have two worker nodes, and we have here the status is up. Now let's try to verify, make sure that it's actually running. Now, if you will notice, earlier we tried to do the cluster command, and we actually got the error here. It says a kubectl not found. Now we will verify. We will type the same command to get the nodes. Now you can see that without us installing anything, the FabDep actually will deploy everything for us. So now you can see we have a cluster composed of one master node and then two worker nodes, and it's up and running right now. Okay, so everything is done for us. Now, if we do the docker command, sudo docker, it's actually running now our Kubernetes. So that means the FabDep was able to deploy also the Docker system inside the master node. Now you can see here a lot of Docker container. This is actually the Kubernetes cluster running. Okay. Now we have a cluster. The next step would be now to create our Fabric network, and we don't have to do anything to manually deploy. Everything will be automated in the dashboard. Okay, so first let's create now our Fabric network. Let's put a name here. This is a Wrappy Fabric network. If you will notice, we can actually create multiple clusters of our Fabric node, but in our presentation, we'll just use one single cluster. But you can actually select. So if you have multiple cluster, if you want a multiple cluster setup, maybe you have one cluster in Japan, maybe one cluster for the US, you can do that here. You can create multiple cluster. It doesn't matter. Everything will be handled by FabDep. Okay. So the very first thing when we create a Fabric network is we have to register a registrar. What is a registrar? Registrar is responsible for the registration of everything inside the Fabric network. For example, if you want to create a new organization joining the network, it has to be registered in a registrar. That means the registrar is responsible for registering members of the Fabric network. So let's try to create the admin account. So registrar admin, and let's just type a password here. Okay. One of the reasons why the FabDep allows you to register a registrar and register your own secret or password, so that when the time comes, when you want to do it manually, you can also have the access. You have the credentials how to access the Fabric network from within the command line. You can do it manually instead if you want. That's why you can register your own. So first, let's try to create a network. Let's try. Network is required. Let's try to do it again. Okay. Now it's creating. We don't have to do anything. Basically, what the system will do is it will download all the Fabric images, create all the Fabric container for us, and then add it to our Kubernetes cluster. So first thing, it will register a registrar. That's why you can see here a registrar. and then it will create a TLS CA. So what is a TLS CA? TLS CA is responsible for creating all the certificates for the registrar. So we'll wait for a while. So let's go back to the third node that we are creating. Let me try to connect now. Okay, so this is the third node, because we will try to add this later on dynamically. So let me just update just to make sure we're on the latest software. Okay, now in the meantime, I have created now our register, and we have a certificate authority already registered here. So once you have created a registrar, now we will try to issue certificates into the member organization. Now to do that, first we have to register a root CA. So just like in SSL certificate, everything has a root certificate. So we will register our root CA. We call this the root certificate. And also, again, we will try to use which cluster you want to deploy. Root CA admin, and then we specify a password. So here, since we are registering, we always have to register our own password. So in this way, you can do it manually later on. That's why we have this option. Okay, so we have registered a root CA. Now, every time we register a CA or we register our organization, it will be deployed to the cluster. That's why you can see here, it's deploying. It's creating a service in our Kubernetes network. That means in a cluster mode. So let's go back here in the meantime, and I'll just want to make sure that our third node, because we will add this later on. I just want to make sure that it's on the latest update. Okay, now let's go back. Okay, now we have a root CA. This is the CA responsible for issuing certificates to all the member organization. Okay, now this is the most interesting part. Now we will create member organizations. Now there are two types of member organizations in Fabric. One is the peer organization, which is the consortium member, and the other one is the orderer organization. So two types. So first, let's try to register an orderer organization. So we go here. Let's create an orderer. So in your orderer organization, you may, in your Fabric network, you can have one or even more orderer. It depends on your setup. In our presentation, let's just create one single orderer. We call this the orderer. This is an organization. And then we will create the MSP. MSP means membership service provider. So this, within the orderer, there's also the membership. Within organization, there's a membership. So you have to be registered. So let's say this is orderer MSP. And again, because we are in the cluster mode, we have to select which cluster you want to deploy. So a typical scenario, you can also create a dedicated cluster exclusively for orderer. You can create a dedicated cluster exclusively for peer members. It depends on how you want to set up. Right now, for this presentation, we're using just one single cluster for orderer, although within the cluster, there are multiple virtual machines located in different locations. But if you want to highly organize, you want to create a different cluster for orderer, different cluster for peers, you can also do that. Okay, so in this case, we'll just use the Wrappy cluster, and we select the root CA. And also, since we are creating an organization, we will now create an admin also. Okay. Okay. Now we will register the order organization. Later on, let's create first the organization, and then we will link the organization together. So in the meantime, let's just create the orderer organization first. Okay. So now we have our organization, orderer organization with only one member, just for this presentation. But you can actually, if you click on this button, you can actually create different kinds of organization, order organization, multiple. Okay. Let's go now to the peers. We will try to create an organization for the consortium member here. Okay. So we will create one. We call it the Wrappy consortium. You can use basically any name. And then we will select which cluster we want. And since we have an organization, we also have the CA admin for that specific organization. So what is a CA admin means for an organization? So if I create an organization, let's say a banking organization, within the banking network, they can also create multiple peers. And we will use this particular certificate to actually register a member of the organization. So let's try to create. Okay, just verify the password is correct. We will save this one. And then we will create the peers. These are the committing peers. Now I will explain later on what are different kind of peer, but for now we will create two peers. So we call this one the peer number one. So within the membership, we just create two peers, but you can actually create as many peers as you want. Okay. And actually, you can even add later on if you want. Now let me add one more. We call this peer number two. Just make sure the password is correct. Okay. So this is a consortium organization with two peers. Okay. So now we will add this one. Now this is the interesting part. Once we deploy this one, FabDep will automatically set up the Kubernetes services for our cluster. Okay. Now here we can see we have a peer. We can actually view, verify. Okay, this is the information. Okay. Now, just to show you how many peers we have, we go to the peer here. Now you can see we have peer one and peer number two, and which particular organization they belong. Now remember, we can create as many organizations here, and you can add as many peers also here by just clicking here, create, and you can add. So if you have, like for example, I want to create a peer number 3, and then you can select which organization it belongs. Okay, so you can create as many as you want. But in this example, we have one organization with one orderer, and then we also have the consortium member with two peers. Okay, now here's the thing right now. I have my peers. These are actually committing peers. These actually are peers that actually saves our ledger I have here. But right now, we have not linked the orderer into the peers. Not yet. That's why we will now create an orderer service. That's the next step. So what is an orderer service? This one. Ordering service means we will assign the orderer to a particular peer where he belongs. So we are now linking the orderer organization into the consortium member peers. Let's try to do that. Okay, so we call this, let's just put some names, ordering service. Now this is interesting. In a previous example of deploying in the Fabric network, normally we use the solo. But in a FabDep, actually this is a feature of Fabric 1.4x. Now there's the wrap. This is the fault tolerance consensus now supported. Now in this case, let's choose the wrap consensus. Now this is the interesting part. First, you select the orderer organization, which we registered earlier, and then you select which consortium. So you can see we are linking the consortium member into the orderer. So what this means is this consortium, actually you can select multiple consortium. This consortium will use this orderer organization, and we will use the wrap consensus. So this is a definition of an ordering service, how the orderer is related to the consortium. Okay, now we have the wrap. Now let's create this one. Now, interesting part, we don't have to do anything. We just have to define our workflow, and FabDep will do everything for us. I will demonstrate that later on how to verify. Okay, so we have created now the ordering service, which is actually linking. Now you can see here, this is the rough type. See the details here. Okay. Now we are what this ordering service means. We're telling this particular consortium is using this particular orderer's organization and using this particular consensus wrap. Okay. Now we have a Fabric network running. Let's try to, at this point, let's try to just to make sure that we verify that. Let's try to log into our here. Okay, so this is one of our node number 1. Sorry. Okay. Now you can see here we have our node is now running we have the Couch TV for state database. We have the peers. We have the Kubernetes also running, and we have the orderer also running for the 2 peers. Okay. So everything is done by the FabDep to deploy. Now let's go to the next step. The next step is channel. Now this is very interesting because this might be very important in future use. So what is a channel? So for example, I have, let's say in my Fabric network, I have 5 peers. Sometimes everybody will talk inside the peer. All the member peers will communicate inside one single channel. But sometimes peer number 1 needs to talk privately to peer number 2. So for example, if I am just in a typical use case, if I am a vendor, I am selling let's say for example medicine or a medicine, I could have different buyer, but I sell different prices to them. So buyer A, maybe from China, I sell $1 for the medicine. Buyer B is from the US, maybe I sell $2. Since I don't want all the network to see the price, I want to create a private communication channel with US buyer and the China buyer. So what I will do is in my workflow, I will create 2 different channels, and whatever activity between the private channel will be stored only on the member peers of the channel. That means China cannot see whatever price I gave to US, and US also cannot see the price that I gave to China, because whatever transactions I made to them are stored privately in a what we call the private data in the peers. So this is how you create a private communication channel exclusively for a specific purpose. But in our case, like for example, let's try to create a channel. Let's say this is the Wrappy Global. So Wrappy Global means everybody can talk to each other. So we select the ordering service that we have created earlier. We choose the operators. Now here, you can specify which peer belongs to which organization. So in this case, I select all the peers, meaning everyone can talk to this channel and they can see the transaction. But if I select, let's say, peer 1 and peer 3, for example, peer 2 cannot see it. Only peer 1 and peer 2 can actually see the private transaction. So that's how channel works. The channel means it creates a virtual channel where you can talk privately. But if you want to make it global, then you can assign all the member peers into the channel, meaning everyone can see and have a copy of the ledger. So by the way, I just want to clarify, once you are communicating in a channel, once you save the transaction will only be saved on the peer specific to that particular channel. That means all the other peers that do not belong to the channel, they will not get the data. They will not be saved on their ledger. Okay, that's why there's a privacy tag. So this is actually a very important features of Fabric that allows you a private transaction to a specific peer. So in the future, we might be able to use this one. Okay, so in the meantime, this is a global channel, so meaning all the peers are included here. So we will now add the peers. Okay, now our network is complete. We have the channel, we have the ordering service. We can see everything here. Let's say we have a node here. Node number 2 also has the running. Node number 1, we also have the running the Fabric network. Next step. Now, okay, so I have now a running Fabric network maintained by FabDep. Let's try to deploy our chain code. Okay, so this is the next step. So in the chain code deployment, there are 2 steps. One is the installation of the chain code, and the other one is the instantiation of the chain code. Install simply means copying the chain code into the peers. That's all. It's just copying. Instantiation means running the chain code inside the peer. Okay. So in this case, let me copy our example Wrappy chain code that we developed just for presentation. Okay. Let me okay, so I'm connected to, in this case, we'll just have, I have here example of the chain code that we have created. We will try to deploy this one to our peers. I'll just copy it to the server. Okay, so I have uploaded this one. This one is called the chain code Wrappy.zip. So it's actually our convector-based Wrappy chain code. I think this is the guild. Okay, now let's try to deploy the chain code. We call it, for example, Wrappy. Let's call it Wrappy in this example. We specify the version. Versioning is very important because we might have the update. So we will try to increment this one 1.1, 1.2, 1.3, and so on and so forth. So in this case, this is 1.0. Our train code is based on Convector, which is a Node.js. Okay, so I have here the chain code. Now, this is the important part. We will select which consortium we want to deploy this one. Now, that's why earlier I mentioned about the concept of committing peers, because right now the consortium has 2 peers, but when I deploy the chain code, I have the option to just deploy it in 1 peer, not the peer number 2, or I can actually choose both peers. What will happen if I deploy only on peer number 1? I will not include the peer number 2. So what will happen is that the peer number 2 will just be a committing peer. So what that means is, if I execute a transaction on peer number 1, create a proposal on peer number 1, the peer number 2, once the transaction has been approved by the orderer, has been processed by the orderer, his only function for peer number 2 is basically just to save the transaction in the ledger. It cannot create a transaction proposal because there is no chain code running in peer number 2. So what it means, peer number 2 will just receive the transaction, but it cannot create a transaction proposal. Okay, so that's the difference. But if I deploy it on peer number 2, I can also create a transaction proposal on peer number 2 because a chain code has been deployed. Okay, so that's why there's an option whether you want to deploy in all the peers or you just want to have the peer to be a committing peer and create action proposal. That's why it gives you the option. In this case, let's just, for our example, we will deploy on both. But in real scenario, it's an executive decision to whether to deploy on all or just deploy on a specific peer. It's more of a workflow decision. Okay, so in our example, we'll just deploy on both, and then we will click add. Okay, so now we have deployed, installed, sorry. We have installed our rapid chain code inside 2 peers and under the fabric network that we have created. But again, this is only install. Install simply means copying the peers, copying the chain code. That's why if we go back here, let me show you. If we go to the node, let me see if you can see. You cannot see our chain code running yet because it has not been instantiated yet. It's still empty. Okay, the same here. If we use the Docker command, nothing here is running in the chain code because install simply means copying the chain code into the peers. To be able to make it running, to run the chain code inside the fabric network that we have created, we have to instantiate. That's why that's the next step. Okay. When you instantiate, you have to select which channel you want to instantiate. So we will use the channel global. Now, this is the interesting part. If you look up here, there's an endorsement policy. So endorsement policy means in a consensus, do you allow and or? Or means anybody in the member network can actually approve a transaction. But if and, it has to be a majority or all. Okay? Or means only one. So it depends on your workflow of how you want the endorsement policy to be executed. In this example, we'll just use the and, but you can actually have the advanced option also. Okay. Now, instantiation actually will take a little while because this will actually what we call this install all the dependencies. So let's instantiate. This will take a while, but I will demonstrate why this will take a while, because it's actually compiling and then installing all the dependency of the chain code. So I will demonstrate what it's actually doing from behind the scene. So while waiting for that, let's see. I'll demonstrate here. So first, these are actually fresh machines, so I have to do it manually, everything. So we will install the node. Node is the dependency. So in this case, we will install the latest version of the Node 10. So let me separate the window so you can see the activity. Okay, so we have installed now. Just to verify. Okay, so we have the node installed. We will install TypeScript. By the way, our chain code is based on convector, so we will use the TypeScript compiler as well. And we will install, since we are using monorepo concept, so we will also install Lerna. Lerna is a monorepo dependency platform. Now I will copy the source code. This is actually to demonstrate why instantiation will take a time, but this is only one time because it will install all the dependency, and I will demonstrate that how it works. So I will basically copy the source code of our chain code here. Okay, so you can see here the models, certificates, and everything. Oh, okay, it's completed here. Okay, so we have uploaded. Oh, sorry. Okay, so if we go to the chain code, oh, okay, it's done. Sorry. Okay, so we have instantiated the chain code now. We can verify that, but in the meantime, let me show you first. Sorry, I set up in the master node. I should copy the files into the master node. Let's see. Okay, so I copying the source code into the master node just to demonstrate to you why what's the instantiation doing. Okay, so we have copied now. So what it does is actually compiling like that. So it's something like this. It's actually installing all the dependency. That's why it takes time to instantiate, but it's only one time. Once dependency has been deployed, it's already there. You can just basically upgrade your chain code unless there's a new dependency. So that's why it takes time to instantiate. But right now, we have already completed the instantiation, and we can verify that one. If we go here, earlier, see, this is the previous Docker command. It's basically nothing here. But if we do the Docker query again, now you can see here our chain code is running on node number 1 here, up 2 minutes ago. We can also do the same on node number 2. We also have our chain code here running already. Okay, now that's how easy to deploy the chain code from within the FabDep. Now question, I have deployed my chain code. How can I access the chain code at initiate? That's quite easy. If we go back to the peers, you can see here the list of peers right now in our Fabric network, and you have this CC port. The CC port allows us to connect to the chain code and initiate commands using this particular port using the gRPC command. So this is how we connect to the port and propose a transaction, create the transaction proposal, and everything. This peer port is how you control the peer. For example, you want to restart or something like that. And this is the DB port, which is for how you want to connect to the state database. In our case, our state database is CouchDB. Now you can connect to the CouchDB on this port. So we just have to find out the username and the password to connect if you want to make the optimization part. Okay, so there are, every peer will have different ports. We have the peer port for peer communication. CC means chain code port, and we have the DB port. Okay, now let's go to the master again. And okay, right now we have 2 nodes. So what if I want to add one more node because the load is now high? I have so many clients or many requests coming to the Fabric network, and I want to create one more node. So if we go back to our cluster here, we can actually add one more cluster here. Okay. Now let's try to do that to verify. Okay, so we have node 1 and node 2. We call this one as node number 3. Now earlier I have created one more node with a different IP address here. This one, node number 3. We will copy this one. This will be the new node. I can add as many nodes, and I can add it in our cluster as many as we want. Okay. So let me just change the password first. Okay. Now let's connect. Okay. Now let's update. Meaning update is we will update whatever changes to our cluster. So just to demonstrate, earlier we have only 2 nodes, 1 node and node 2. So let's try to update. Okay, so what I'm trying to demonstrate now, what if I already have the Fabric network and I want to add more nodes to it? How can I do that? And this is the example. Depending on how much bandwidth or usage. So this is a fresh node. So basically FabDep will set up all the necessary software, including the Kubernetes software, Docker, and everything will be set up. by FabDep. This might take a little while, but not really as so much time as the initial setup that we have when we set up the master node. So right now, what the FabDev is trying to do is just basically set up the one of the single node. It doesn't have to reset up the master node again. So just a few more minutes. Okay, so we're done. Now, if you will notice here, we have the worker nodes. It's 3. We have increased. Now, let's try to verify that from here. So earlier, when I issued the Kubernetes command, we have 2 nodes. Now, let's try to issue again. Now, you can see we have added the nodes, number 3. Now, you can use that to actually update your Fabric network, or automatically it's used by the system when it's available. Okay, so that's how easy we have how we deploy and instantiate our peers, how the clusters being maintained. Everything will be handled by the Kubernetes cluster to initiate updates. Now, if one of the nodes is down, automatically the Kubernetes will execute, make sure another one is created automatically. Make sure it maintains our peers and node is running behind the scenes. So it's maintained by the Kubernetes cluster already, because we have the FabDep already defined the different services to make sure our Fabric network is always running. And that's why it's very important to have a node running on different locations, like in our case, so that not only for load balancing, but also to make sure that it can be accessible when one is down, automatically another one is created on the different node. And we don't have to worry about that because that's being maintained by the Kubernetes itself. Okay, so we have our Fabric network running. We're able to install our chain code. We were able to initiate our chain code. We know which port to connect if we want to propose a transaction. We're able to assign order into the consortium members. We're able to select different consensus type. In our case, we use the wrap consensus.